All right. Okay, beautiful. So, hi everyone. Welcome to another Hudson and Thames Reading Group talk. I'm Michael. I'll be delivering the talk today, and we're going to be covering a paper that has the title Can ChatGPT Forecast Stock Price Movements? But what's interesting is we're going to, I'd say maybe 30% of this talk, or maybe 40% is actually about this paper. We will be examining large language models and transformers and sentiment analysis and all of these things in the broader context of kind of predicting returns. We're also going to critique the paper a little bit. We're going to talk about some shortcomings. We're going to talk about how to do things better, and maybe also a little bit of analysis on what the risks on relying on something like a large language model that sits behind an API. And if there are any open alternatives that can help us do sentiment analysis where we're not entirely dependent on a black box that we have no control over. So without further ado, let's get started. So the main thesis behind this paper and behind why we do sentiment analysis is that information about an asset is what informs its price, and news represents new information. That's why it's called news. So there's new information that comes in the form of news. From that news, we can analyze the sentiment, which kind of contextualizes the new information coming in, whether it's good news or bad news. And then we can use the sentiment to predict the underlying price of like the asset. So the idea is you go from information or news to sentiment to a price prediction. So that's kind of what the thesis of this paper wants to explore. And its argument is that we can use these large language models to do the sentiment analysis. And so the big idea is if there's positive news, the underlying asset will go up in price since it's considered more valuable or more likely to yield returns in the future. And if there's negative news, then the price will go down. So that's the kind of general sentiment about how, no pun intended, about how sentiment analysis can help us forecast, the pricing of a certain stock or asset. But I do think it's worth mentioning what sentiment analysis is, since not everyone's going to be familiar with the topic. And so just move this out the way. So essentially, sentiment analysis has a goal, and the goal is to identify the emotional tone, aka the sentiment, from only the words themselves. This is a subdomain of NLP, or natural language processing. And humans are really good at doing this intuitively. We can read a headline and understand whether it's positive or negative, that kind of thing. And so as an example, here are two sentences. So on the left, I had a fantastic time in Cape Town over the summer. And on the right, I really hate sitting in traffic. It's pretty easy for us to infer that the example on the left is positive in its sentiment, and the example on the right is negative on its sentiment. But unfortunately, language is never quite this simple, right? So what about this example? I don't dislike working long hours. And this one is a little bit tricky because you have this double negative, right? I don't dislike. So is this actually a positive sentiment towards working long hours? Is this a negative sentiment? This is something that could confuse humans as well, especially if you're a non-native speaker, right? And what about if you see a confusing news headline such as Tesla sees growth as competition begins to fail? You have a positive word like growth, but then you also have a negative word like fail in the sentence. And so if you can imagine we're trying to build some kind of model that will be able to detect what the sentiment is, it's not entirely clear whether this will be positive or negative. We understand it's positive, but a model might not. And the other kind of problem you face in sentiment analysis is attribution. It's positive or negative, that we can maybe tell, but it's not entirely clear for who. So in the case of IBM loses a court battle with Microsoft over AI technology, it's negative for IBM, but it's positive for Microsoft. And it's not super obvious how a model will be able to tell which is which. Okay, so now that we kind of understand why sentiment analysis is hard and what the problems there are in that domain, let's figure out how it's done. So there are a couple of classical approaches to sentiment analysis. If you were doing NLP a couple of years ago, you're probably familiar with a bunch of these. So we have handcrafted features like engrams, parts of speech tagging. We have these sentiment lexicons. We use some basic machine learning like naive Bayes to classify the sentiment based on the words and how frequently they occur. That's kind of how we were classically doing things. And we'll actually be exploring some of these a little bit later in the demo too, and show you why they're not that great. And we also have things like sentiment lexicons. So what you do is you have panelists get a whole bunch of words together. You rate how subjective they are and what sentiment they typically evoke. The problem obviously over here is that they don't have context. So sentiment lexicons are cool, but they don't really help with attribution. And we've also seen, classically people look at things like both the syntax and the semantic information. So we're looking at context, we're looking at semantic meaning, we're looking at higher dimensional data. So we can also use input features like looking how frequently words occur, the role that they play, when Sally kicks the ball, who's the subject, who's the actor, that kind of stuff. And we can try and piece together the sentiment. But in the more kind of like recent history, we've been looking at using deep learning models and neural nets to do this. So you have, recurrent neural networks and LSTMs, long short-term memory networks, that operate, they walk through and ingest, each sequence bit by bit, and they update their internal state. And at the end, you have some kind of representation, which you can do a classification on, maybe lift out the sentiment of that sentence. That's been, really, really popularized before. We also look at having embeddings. So word2vec is the famous one, and GloVe is also quite famous, where in this kind of multi-dimensional latent space, we see that cat is similar, is close, in that space to dog. We see that king is close to man, queen is close to woman. And you can also do these weird kinds of manipulations where you take king minus man plus woman, and that lands you up, very close to queen. And so these embeddings, these super dense embeddings, they have some kind of representation of meaning. And I remember when word2vec came out and the paper was published and how this works, a lot of people thought this is amazing. We're starting to extract understanding. We can figure out the context of these things. And then the follow-up onto that was a way simpler idea, which is using transformers with an attention mechanism and foundational models, which we would fine-tune. So you got things like BERT, which I believe Google was using it for Google Translate at some point. There might still be. There's a variant of it called Roberta. There was GPT-2, and then, ChatGPT or GPT 3.5 and GPT-4. And that's kind of what the current state of the art is for doing sort of this kind of analysis. But I guess you can't really mention ChatGPT and GPT-4 without talking about large language models and why they're fundamentally different from a lot of the other stuff we've seen before. So I want to spend a little bit of time kind of explaining why these things are a big deal. So let's talk about how transformers, which is what the current best in field crop of large language models are based off of. And essentially what they do is they can look over an entire sequence of data in one go. And crucially, what sets them apart is they have this attention mechanism for weighting inputs. So based on the next token that you're trying to predict, you can pay weighted attention to other words that have come before or after that word and kind of look at both the input sequence and the output sequence that you've generated. So if you were trying to predict, let's say, the word sat over here, you would pay attention to cat. Or if you're trying to predict the word mat, which is where the question mark is over here, you would say, there is a cat and it is sitting. So you would weight those inputs and probably infer that the word is mat. And so attention is this amazing, very simple idea of paying attention selectively to previous words every time we try and predict the next token. And so these models they have a very simple objective, is just predict the next token in the sequence. And we let gradient descent take care of the rest. And somehow magically the attention mechanism just works. So if you'd like a slightly more technical overview, we covered this, how the key query value lookups work, a little bit more in depth of how the attention mechanism works mathematically and conceptually. So our Bloomberg GPT talk is available for free on YouTube. I think it's a really good one. So what you can do is just search Bloomberg GPT on YouTube. You'll see the Hudson and Thames video, and you can go for a bit more of a deep dive into how these transformers work. So I'm not going to cover it too much yet. But what's fascinating about these LLMs is they have these emergent properties, right, which no one thought they would have. So they're what's known as few-shot learners. What that means is in the prompt, when you're prompting ChatGPT or even, GPT-2 way back when, you can give them examples. So an example of few-shot learning is essentially what happens is you can give an example of the problem and the answer to the problem multiple times, and then the model will essentially infer the task that you're trying to ask it to do. So for example, you'll give a sentence and say, the following sentence has a spelling error. Here's the corrected sentence, and put in the corrected sentence. Then say, here's another sentence with a spelling error, put in the sentence, and then ask it, what is the correct spelling? And so essentially what happens is by just giving these examples, you can teach the large language model exactly what the task is that it's supposed to do. And this paper, which I've linked here, is absolutely fascinating. They essentially look at what's happening to the model weights, and they discover that the model looks at the actual tokens, and the attention mechanism looks at the tokens, and the model actually approximates a gradient descent procedure locally on the actual prompt itself in order to figure out what it has to do. And so this is quite amazing. It can do this. These large models can approximate, a gradient descent procedure without updating any of their weights. So they just have this built-in property, this emergent property, in fact, where they're exactly able to learn new tasks that they've never seen before. And this is why it's considered few-shot learning, because they need 1 or 2, up to 5 examples of how to do it, and they magically figure out the task that you want to do, even if it's a task that they've never been trained on or exposed to before. So that's quite amazing. And then there is another recent discovery, more recent than the few-shot learning one, which turns out that these large language models are what's known as zero-shot reasoners. And so it turns out all you have to do with, let's say, a ChatGPT or GPT-4 is you just have to add to your prompt, take it step by step, and explain your reasoning. And what will happen is at each phase of producing a solution to the problem that you've asked, the large language model will actually explain why it's saying what it's saying. And it turns out that just asking a model to go step by step dramatically improves its accuracy, almost like when you ask a person to talk you through the problem or the problem they're having. Maybe they're struggling with some code or whatnot. Oftentimes, them just talking through the problem and rubber duckying with you ends up getting them to an answer sooner. And so this is quite an amazing paper that I highly recommend people read, because it's useful to update your own prompts in this way. And so it turns out, without even being given an example of how to reason about solving a problem, just asking a large language model to explain things to you step by step helps them with this task. So they're few-shot learners and they're zero-shot reasoners, and they're generalists, and they can do all of these different tasks. And, naturally, if they're really good at these general purpose tasks and learning new ones, it's reasonably likely that you can infer that they'll also be good at sentiment analysis. And what's fascinating for me personally, and why these things are so exciting and why people are freaking out and all of this other stuff, is because all of this behavior is emergent simply from asking these models and training these models just to predict the next token. That's all they're trained to do. And yet you have this emergent property that comes out of being able to learn new tasks and explain why you're doing stuff. It's kind of fascinating and quite extraordinary. But at the same time, one of the famous things you always hear if you're a trader is, don't be fooled by randomness. And that key argument that they're just predicting the next token, it's really important to understand that, I still kind of look at large language models for now anyway. Maybe this will change in the future until we understand how they work, but I still kind of consider them stochastic parrots. They're just really good at giving you answers that sound sensical, are hopefully based on information that the model has seen before or retrieved and summarized. But we can't just outright trust these things. This isn't intelligence yet, I think. People will come at me for that. But I think we're on our way there. But it's important to understand that these models still only do one thing, which is predict the next token. They're still sampling from a probability distribution when generating tokens. And so don't be fooled by randomness. These things are not foolproof. They often have failure modes, stuff like that. So just keep in mind, these are still to some extent stochastic parrots, and they're really good at passing the Turing test. But let's not get too ahead of ourselves and trust these things just unconditionally, right? We need to understand what we're dealing with, and we're dealing with models that just predict the next token. Okay, so that's kind of a little bit of a background on sentiment analysis and why large language models are awesome. Let's talk about the actual topic, which is using ChatGPT for forecasting and how this all pieces together and how it works. So here's how their pipeline works. They looked at stock return data from the CRSP, which is an institution that will sell you data. And then they scraped news data, and then they were using Ravenpack in order to both look at that as a baseline. So what they did is essentially they would then take this scraped news data and they would match it with the Ravenpack's news in order to make sure that the news was actually applicable to a certain security. Once they'd done that, they would then use ChatGPT with a specific prompt that would invoke sentiment analysis out of the model. And then they would apply that sentiment analysis to the filtered news headlines. And then based on when the news headlines occurred and the sentiment output from ChatGPT, they would then trade these securities, right? And try and make money that way. So let's go into the stuff a little bit more in detail. So the data that they looked at is from October 2021 to December 2022. What's interesting to note about this is at the time, ChatGPT was only trained up until September 2021. So everything here is completely out of sample. They have to if it's the model you don't control, right? So they did that. For me, a key limitation of this approach is they're matching news with Ravenpack. So my argument is if you're going to scrape news, and then anyway, just check whether that news is in fact in the Ravenpack database and that it also applies to the security that you're looking at. I don't understand why you bothered scraping the news. Why not just use the Ravenpack data? So I think that's kind of a key limitation and weakness of this approach. Yeah, if you need someone else, and we'll talk about the nuances of this a little bit later, but if you need someone else to fetch the news for you, that's kind of already not really solving the problem. And it would have been amazing to be able to get away with not needing Ravenpack since it's quite expensive. And so, yeah, this is a key limitation. A weakness is having to rely on an additional third-party tool with some kind of lookup stuff that'll help you figure out which news is applicable to which security. It's kind of half the problem. So that's a key limitation and weakness. And then when I looked at this, I also think that the prompt that they used is not the best, let's say, and we can improve it. And so, you know, let's take a little bit of a quick aside and talk about prompt engineering, which is one of these things that you have to do when you're working with a large language model. And let's try and do it better. So let's take a look at the prompt they used. So on the left, we have their prompt, and it goes like this: forget all of your previous instructions. Pretend you are a financial expert. You are a financial expert with stock recommendation experience. Answer yes if good news, no if bad news, or unknown if uncertain in the first line. Then elaborate with one short and concise sentence on the next line. Is this headline good or bad for the stock price of company name in the short or long term? And then they put in the headline. This isn't a very good prompt, in my opinion. I'm not an expert, but I've spent a lot of time playing around with prompts and generative models. And so this set of instructions would even be confusing if you gave this to a human to do, in my opinion. It's not quite clear exactly what you're supposed to be doing and what the output format should be. So if I was an intern and this is the job you gave me, I'd be like, okay, I'm not quite sure. And so taking the idea that they had there, I've got a little bit of a better prompt, which I think will be a bit more robust. And so the better prompt that I think they could have used, which will probably eke out a couple more percentage points of performance, is pretend you're a financial expert with stock recommendation advice. Given a headline in a company, answer yes if the news is positive for the company, no if the news is negative for the company, or unknown if you are uncertain. Give a single short sentence explaining your rating. Use the following output format. And then I give the output format and the headline. This is a much nicer way of doing this. It also makes it easier to post-process after the fact. So this kind of is a better prompt that I think they could have used. But what's interesting about this, and something that I think is quite fascinating, especially in light of new research we're going to cover in a second, is asking a model to give an explanation, right, that's similar to the zero-shot reasoning. So the model is being asked to give a reason why it's actually chosen yes, no, or unknown. And so this kind of brings up hallucinations and confabulations, which is what happens when an LLM doesn't actually have the answer. And you're asking it to make up a reason. You're putting a gun to its head essentially and saying, just give me a reason why you've given this certain rating. And that's a problem. And so let's talk a little bit about failure modes and what happens when there's hallucination. And it turns out there's new research that's recently come out, which discovered, I guess, that LLMs know when they don't know something. They're actually aware of the fact that they're busy making stuff up. Also, there's been a bit of movement in the language. I think confabulation is a better term than hallucination. It's a psychiatric term that comes from when you're dealing with patients that maybe have had some kind of brain damage or brain injury, and their memory is failing, and you ask them something, they will just start making things up and generating reasons. And so that kind of mirrors what's happening when these large language models either don't have memory to fall back on and they're being forced to give an answer. It's important to remember, that in when they've been trained, I don't know was never an answer. You're just always told generate the next token. And so there are some manual guardrails to prevent this. I'm pretty sure you've asked ChatGPT to tell you something that it doesn't know. And it says, well, I'm just a large language model. I don't know. Those are manual guardrails. But it turns out that there's research now that these large language models actually know when they're confabulating, right? And so I've linked 2 papers there for you to kind of go read up on this if it's something you're interested in. But for us who are caring about application, it turns out all you have to do is ask the model how confident it is in the answer that it's given. And it turns out that if you look at that calibration, if the model thinks that it's only got about a 50% chance of being correct on an answer, it turns out that it's actually 50%, it's right 50% of the time. And so if you have this calibration curve that you look at, where if the model is only 10% confident, it's only right 10% of the time. When it's 100% confident, it's correct 100% of the time. And everything in between is perfectly interpolated. It turns out that these models are really well calibrated in guessing whether they're right or not. That is an astounding insight that I don't think a lot of people have actually become aware of and appreciated yet, which is that just asking these models like, is what you're telling me true or false? They'll actually give you a really good probability of them being true or false. And so we can use this. And so I actually wanted to improve the prompt even further by asking the model, also evaluate the probability P of true that your answer is correct as a confidence score. And then I've asked them to use the following output format. And now what we get is this kind of confidence rating in addition to the explanation that tells us how much we can trust what the model is saying. So if we have a low confidence, we can just say, okay, we're not sure we can trust this. And this also gives the model an escape hatch to stop itself from hallucinating. It can now let you know when it's probably telling you something that it itself thinks isn't quite true, even if you're forcing it to give you an answer. And so this is something that I think we can also use this kind of new research to improve the prompt. And then lastly, how does the trading work? So if the news happened before 6 a.m., the algorithm will enter at the market open and exit at close. If it's after 6 a.m., it'll enter at the close and exit at the next close. And if it's after 4 p.m., it will enter at the next open and exit at the next close. So there's some constraints that you won't just be able to enter and exit a position immediately. And also there are a bunch of different configurations, but the model will be able to short stocks with a negative sentiment and go long, obviously, in stocks with a positive one. Okay, so now that you kind of have an understanding of how this works, how good is an LLM at sentiment analysis? And so here's a graph of the cumulative returns. It turns out that this works like really well. GPT-4 has a 3.8 put on share ratio, 3.8 Sharpe ratio over there. The results are also statistically significant. So they did regression analysis on this. It looks like there's statistical significance here as well. And even if they add in transaction costs, the results don't really change that much. They have to add a ridiculous level of transaction costs, unrealistically expensive transactions in order to kind of mitigate this. And yeah, what's amazing is also the ChatGPT-4, the GPT-4 long short portfolio only has a maximum drawdown of negative 10%, which is pretty amazing. So it turns out this works. And if you look at, the market value weighted and the market equally weighted, it just rapidly outperforms tracking the market in this period from October 2021 to now January 2023. Amazing results. Just super fascinating. It works. It's statistically significant. Yeah, all around, like amazing stuff. And it works better than any other kind of language model that they've tried. I see there's a question. Just a comment. Wow. Yeah, it's pretty astounding. And it works better than things like BERT and GPT-1 and these other large language models. It just works. These models are incredible. So wow. But there's always a but. Whenever I give a talk, as you guys should know by now, there's always some kind of catch to this thing. And the big risk I see here is the over-reliance on black boxes that we don't control. So there are a couple of things I want to raise about this and why this isn't just a get rich quick scheme, right? So ChatGPT is a black box on a closed platform. We don't get access to the model weights. We have no control over how OpenAI manages the model. They could change the price. They could change the policy. They could change how you access it. They could change the underlying model, which, by the way, they've done in the past. They can restrict certain use cases. They can change how the licensing works. And they could also give this away, the exclusivity away to someone else. And you could, I mean, an objective you'd probably say is, yeah, sure, but they can do that. Like Ravenpack could do that, right? Anyone could do that. And it's true, anyone could do that. The difference is in the large language model space, there's not really many alternatives to choose from. And so OpenAI might not be punished very harshly necessarily from kind of making that decision. There are, BERT is out there and things like that, but, ChatGPT and GPT-4 are still kind of considered, best at this by quite some margin. And subjectively, I still think they kind of are for most use cases. So here be dragons. Be aware. Be careful of relying on things you don't control. A lot of tech businesses have been bitten by this, and I see no reason why a hedge fund won't be the same. So just be cautious. The other issue is alpha decay. No edge lasts forever, especially if it's just a single API called away, right? And so what might happen over time as more and more investors start using these models to do sentiment analysis and factoring that into their strategies, you'll probably end up converging to the market over time. We know this happens whenever there's a new technique that kind of gets discovered, and typically you want to be uncorrelated to the market. So there's that. And the other thing that someone pointed out to me on Twitter today is you could also get a weird kind of extreme volatility example where if everyone is using this, you can get dogpiling where negative sentiment comes out and everyone just sells and you see like this price crash on a certain asset. So you've kind of got to be careful how this will influence, especially in like the more and more technologically sophisticated world, how you have these second order effects as a result of people starting to use the same thing, especially because there's only one like really big player in the game at the moment. You have to become aware about how that will influence the market and being able to hedge and maybe bet against that. And then also one of the things to keep in mind is this testing period was very close to where, the training data stopped, and you don't know what's going to happen. The relevance will disappear in the learned knowledge as time goes on. Maybe Tesla, for example, moves into different markets, stuff like that. And the large language model might not be aware of that and so give bad ratings. Maybe they exit certain markets, that kind of thing. Maybe they've taken on an amount of debt, which gives you context for whether news is good or bad, like an interest rate goes up or whatever. So this can maybe be mitigated by internet browsing where you look up information. But the problem is when you do that is it's obviously not going to be good necessarily as curated news data. You then become influenceable by bots tweeting out certain things or like news being generated because someone's got a short position on a stock. Like you start opening up yourself to risks here. And so that's kind of where you've got to be careful about as time goes on. I mean, these things are expensive to train, right? As time goes on, how relevant will that information still be? And so you've just got to take this into account when dealing with these kinds of things. But yeah, the black box / closed platform is for me the biggest risk personally. Okay, so let's say we want to kind of mitigate these risks. Are there any open alternatives that we can do when it comes to sentiment analysis? And so this is where I'm going to exit the kind of presentation and give you guys a little bit of a demo for, maybe there is. All right, so let's quickly do the demo. I'm just going to move. Before I do the demo, let's see. There's a question here. Does the model performance correlate with the parameter count? They didn't say something about this, but I guess it's presumed, the more parameters you have, the more freedom the model has, the more it can hypothetically discover complicated behavior. So there is a common understanding that, bigger model leads to a more sophisticated kind of and more advanced ability to do lots of different tasks. There's also evidence that suggests that we have models that are way too big for the amount of data that we're feeding them. So there are a whole bunch of laws that seem to be coming out of that as well. But yeah, bigger model better is currently the kind of take du jour, I guess. All right. So let's take a look at if there are some open alternatives to sentiment classification. So the first thing we need to do is fetch some news data. For that, I'm using News API. So you guys can kind of go take a look at this and use this to read in news. It's quite fun to use, and there's a free tier that you can use, which isn't too bad. All right, so here what we do is we import just the OS module and request, so we can make an API request. I get my API key, set the endpoint to just fetch that, and then I just extract from the response the titles of all the headlines from some of these stories. So we have things like Uber will now pick up your packages and take them to UPS. Apple stock is falling after a downgrade. Stock futures dip slightly after Dow turns negative for 2023. Things like that. Starbucks to close 7 San Francisco stores by month's end. So these are all kind of headlines in the news sector that are useful for us, maybe for our investments. And so I'm going to look at 2 basic sentiment analysis using the text blob library. And so the text blob library, it's free, it's out there, it's pip installable, all that stuff that we're familiar with. And there are 2 kind of analyzers that it has. It has pattern. The one is the pattern analyzer, which uses the pattern library. This one uses I'll let that load in the background. It's quite big. It uses a sentiment lexicon like we spoke about. So here you can see the different words, how they're used, their polarity, their subjectivity, that kind of thing, and how confident the model can be in its rating when these words get used. So it basically just uses a lexicon. And then the other one we're going to look at is this naive Bayes analyzer from the NLTK library. And this was trained on a movie review corpus. So it probably won't be that good at financial headlines, but we're going to try it anyway. So here's a quick example. We just import text blob and we import the 2 different sentiment analyzers. Here we open a text blob on this sentence. I really love quantitative finance, and we're going to use the pattern analyzer. And we see that the polarity is 0.5, so it's somewhat positive and also somewhat subjective. Okay, so that's just how text blob works. Simple as. And here's another one. I hate cleaning data sets. Same with the pattern analyzer. And we see a polarity of negative 0.8 and a subjectivity of 0.9. So a negative sentiment, but it's highly subjective. And we do the same thing using the naive Bayes classifier. So this one classifies it as positive, but it's only got a 0.5 probability of being positive rating and a 0.45 of being negative. So it's a bit more close. And similarly with the I hate cleaning data sets example, we also see that it accidentally classifies it as positive. So the naive data set, the naive Bayes analyzer that's been trained on movie corpus reviews turns out to not be that great in this particular example. And so let's run both of these. These are the most simplest ones that kind of exist. Let's run both of these on all of our news titles and take a look at what they say. So let's look at the pattern analyzer first. So over here, we see that the headline, Uber will now pick up your packages and take them to UPS, FedEx, or USPS. This is rated as completely neutral. Treasury yields hit new high as bonds extend losses. This is borderline positive, but also pretty neutral. Apple stock is falling after a downgrade. This is rated as neutral, and you would expect this to be rated as negative. So it shows us how some of the sentiment analysis, like falling, might not actually be in that lexicon, which is part of the problem. Let's actually check. Maybe it is. Falling. Okay, so deficient is in here, but falling itself isn't. And that's probably why we're getting a neutral rating. And so this is kind of one of the weaknesses, right, of using a lexicon. Let's see what else. Starbucks to close 7 San Francisco stores by month's end, also given a neutral rating, right? So you can see kind of where the shortfalls are here. Let's do the same for the naive Bayes classifier. Again, It's really as simple as a for loop and making sure we pass in the right analyzer. Let's take a look at some of the same ones. So Uber will now pick up your packages and take them to UPS. This is given a negative classification with a very high confidence. So I guess movie reviews don't translate to financial news. Apple stock also gets a positive with a very high confidence. So in this particular case, the naive Bayes is just atrocious, right? But here's where things get fun. So what happens if we do sentiment analysis using a fine-tuned transformer model called the still Roberta, right? So what this is, it's a transformer model based on Roberta that has been fine-tuned and distilled, which is something else, which I won't cover for today, but it's been fine-tuned on the financial phrase bank data set. And this is essentially a polar sentiment data set of sentences from financial news. It has about 5,000 sentences from English, and it was annotated by 5 to 8 annotators that were rating whether things were positive or neutral. And what they take is a baseline model called Roberta, and they'd fine-tune it on this classification task of giving kind of the sentiment. And if you want to take a look at the model card, it's available here. It shows you what the accuracy is. It's like 98% accurate. There's a whole bunch of details here. It gets about 500,000 downloads a month, which is amazing. And because it's a Hugging Face model, it is as simple as just these 2 lines in order to allow you to use it. Wow. World-class sentiment analysis without ChatGPT. So if we try it again, we see over here, I really love quantitative finance. It gives it a neutral score. So that's an interesting one. And it makes sense, right? Because this might not be neutral in the sense of a regular sentence, but it's probably neutral in terms of a financial headline. This doesn't tell us anything about how a stock or an asset would perform. Same with the second one. I really hate cleaning data sets. But if we then look at something like Tesla announces unexpected increase in earnings, positive with like a 99.9% certainty. So clearly fine-tuned on financial headlines. Very cool. And I didn't have to do any of the fine tuning. I can just rely on the open source community. If I wanted to fine tune this on my own data set, it's also quite simple to do with Hugging Face's Transformers library. So let's run this kind of on the same set of titles. So let's see over here. Uber will now pick up your packages and take them to UPS, FedEx, or USPS. Rates this as neutral because this isn't very clear how this will actually affect the underlying price, I guess. Or am I just fooling myself? This is the problem with these things is humans bring their own biases. But let's take a look. Treasury yields hit new high as bonds extend losses. So that's super interesting. The yields are high, but the bonds are actually extending their losses. And so we see this is negative with high certainty. Apple stock is falling after a downgrade. This is negative with the very high certainty. Let's take a look at some other one. Starbucks to close San Francisco stores, also neutral, so that makes sense. Ripple gets formal approval for Singapore payments license, positive score with a relatively high certainty, things like that. And there we are. So much, much better because it's been fine-tuned on a very specific task on a very specific data set. And keep in mind, hey, this is only 5,000 samples. I think I can't remember now what they used headline-wise in the paper. I think it's like close to 50,000. So you can imagine you can actually make a much better version of this, fine-tuned, or you can be sneaky, get ChatGPT to label them for you and then fine-tune your own model on those outputs. Maybe that's a way of using ChatGPT because it's really good, but not depending on it in the long term and still being in control. So something to kind of keep in mind and think about. But what's amazing is, I mean, this is like trivial code, and you have something pretty darn good that you control that no one can take away from you because it's out there in the open. Okay. And then just as a final point before I kind of open the floor up for questions, I want to talk about the elephant in the room, which is that the sentiment analysis is like only really half of the problem. The other half of the problem is getting the news data and how you need to kind of think about it. So the first is relevance. Headlines will use the stock ticker sometimes. Sometimes they'll use the company name. Sometimes they refer to the company industry. And it's not always very obvious when something is relevant to you or not. The other also is kind of what the effect of the news is going to be. So right now, the assumption is that positive sentiment will mean an increase in stock price. and negative sentiment will be a decrease in stock price. But that's not necessarily true. You know, for example, famously a couple of years ago, Tesla reported really big losses, but because they were a lot less than expected, the stock price actually went up. And so there you would have drawn the wrong conclusion. Like context matters in this sense. And so the sentiment isn't necessarily the same as the effect. In the same way, we looked at previously, and when the correlation talk, that correlation isn't the same as causation. And so I think there's a lot of room for maybe improving this kind of classification by looking at the news and then lagging the stock price and seeing whether there was some kind of influence there. Maybe that's a better way of training a model like this. And then obviously also duplication, right? You get multiple headlines. How do you weight them? Do you weight certain sources more than others? What happens if there's a bias and one set of headlines has a negative connotation, the other has a positive, even though it's the same news? There's all kinds of chaos that can take place here. And so, these are just some of the issues, but reading through the paper, it'll become obvious very quickly that these problems are kind of big ones, and it's not so clear how that works. So just something to keep in mind. It's not as simple as just copy pasting a headline. You need to think a little bit. Luckily, these large language models tend to be quite good at this. So you might paste in an entire set of headlines rather than one by one. Maybe they can figure that out. But the point is there are challenges around news. It's not as simple as just doing sentiment analysis, as I naively thought, reading this paper. Okay, so that's kind of the end of it. This is my presentation. So in conclusion, we looked at sentiment analysis. We looked at large language models, what makes them special, some of the emerging properties, some of the stochastic parrot properties, some of the hallucinations as well. We looked at how ChatGPT is used for forecasting in the paper, looked at the risks and explored some alternatives maybe for sentiment analysis, and then also looked at the real world challenges of news. So this is the end.